Smart contracts unveiled, transforming digital transactions with blockchain technology. Blockchain technology is the bedrock upon which smart contracts are built. Essentially, a blockchain is a distributed ledger that records transactions across many computers so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the consensus of the network. This structure provides an immutable and transparent transaction history, which is crucial for the trustless execution of smart contracts. The role of blockchain in enabling smart contracts is pivotal because it ensures that once a contract is created, its terms and conditions cannot be changed, and it will execute exactly as written. Furthermore, the decentralized nature of blockchain technology means there is no single point of failure, enhancing the security and resilience of the smart contract. This decentralization, coupled with advanced cryptography, protects against fraud and unauthorized manipulation, thereby fostering trust among parties who might not otherwise have any reason to trust one another. The synergy between blockchain's immutable record-keeping, decentralization, and security features is what makes smart contracts a transformative tool in digital transactions and beyond. Ethereum has been a pioneering platform in the realm of blockchain technology, especially known for introducing the concept of a programmable blockchain. It is widely regarded as the birthplace of modern smart contracts. The platform's creation in 2015 marked a significant leap in blockchain capabilities, going beyond just processing transactions to executing complex agreements through its native scripting language, Solidity. Ethereum's contribution to smart contract development is monumental, providing a decentralized environment where developers can write and deploy code that autonomously enforces contractual terms. Smart contracts are deeply ingrained in Ethereum's architecture, making it a go-to platform for those looking to leverage blockchain for more than just cryptocurrency. The ability of Ethereum smart contracts to execute transactions, manage agreements, and even create decentralized applications has had a profound impact on how businesses and individuals conceive and implement digital agreements. The legal status of smart contracts varies across different jurisdictions, with some recognizing them as legally binding agreements akin to traditional contracts, while others are yet to establish a clear stance. Challenges in legal recognition often stem from the novel nature of smart contracts and their reliance on code for enforcement, which may not always align with existing legal frameworks. This raises questions about jurisdiction, the resolution of disputes, and the applicability of contract law principles. However, certain jurisdictions, such as Malta, have taken proactive steps to provide a legal framework that acknowledges the enforceability of smart contracts under specific conditions. In the United States, states like Arizona, Nevada, and Tennessee have passed legislation that recognizes the legality and enforceability of smart contracts, signaling a growing trend towards legal acceptance. As the technology matures and becomes more widespread, it is likely that more regions will develop laws and regulations to address the unique aspects of smart contracts. At its core, a smart contract consists of a set of predefined rules and conditions that are expressed in digital form, along with the automatic execution of the contract's terms when these conditions are met. The structure of a smart contract typically includes a set of inputs that trigger contract execution, the contract's code that contains the business logic, and a set of outputs that result from executing the contract. These components work in unison to facilitate, verify, and enforce the performance of a contract without the need for intermediaries. Smart contracts are predominantly written in programming languages that are designed to run on a blockchain platform. The most notable of these is Solidity, which is used on the Ethereum network. Other languages include Viper, also compatible with Ethereum, and Chaincode, used in Hyperledger Fabric. The choice of language is crucial as it needs to support robust, secure, and accurate execution of the smart contracts on their respective platforms. Common features of smart contracts include deterministic execution, where the outcome is predictable if the inputs are known, transparency, as the code is visible on the blockchain, and immutability, meaning once deployed, the contract cannot be altered. Functions often seen in smart contracts include managing agreements between parties, controlling the transfer of digital currencies or assets, and providing utility in decentralized applications, dApps. By automating processes that were traditionally manual, smart contracts can reduce administrative burdens and provide a new level of efficiency in digital transactions. The execution process of smart contracts begins when predetermined conditions are met. These conditions, encoded into the contract, trigger the execution of contract clauses automatically. For instance, a smart contract for a bet would release funds to the winner immediately after the outcome of the bet is known and verified. The self-executing nature of smart contracts eliminates the need for intermediaries, streamlining the process significantly. Consensus mechanisms play a crucial role in this process. They are responsible for validating the transactions and ensuring that the execution of a smart contract is in accordance with the agreed-upon rules of the blockchain network. This validation is typically performed by network participants, often referred to as nodes or miners, who reach consensus on the current state of the ledger. Smart contracts interact with the blockchain by reading from and writing to the blockchain's distributed ledger. Once a smart contract is executed, the results are recorded on the blockchain, providing a tamper-proof and irreversible record. This ensures that the outcome of the contract is transparent and final, with no room for dispute. The blockchain thus serves as a neutral arbiter that enforces the contract, making the digital agreement binding and reliable. Smart contracts have a myriad of practical applications, revolutionizing various industries by enabling trustless and automated transactions. They are used in finance for decentralized finance, DeFi applications, supply chain management for real-time tracking and verification, and in real estate for streamlining property transactions. In the realm of intellectual property, smart contracts facilitate royalty distribution, and they also play a role in governance systems to ensure transparency and accountability. To create and deploy a smart contract, one must first define the agreement's terms, then encode these into a suitable programming language like Solidity for the Ethereum blockchain. After thorough testing to ensure the code behaves as expected, the smart contract is deployed to the blockchain where it becomes immutable and self-executing. Users and developers should adhere to best practices such as conducting security audits, understanding the underlying blockchain platform, and considering the legal implications of the smart contract to ensure its reliability and legal enforceability. Humans are in charge.com, prompted by a human, performed by machines.